Hi, in the last lecture I mentioned that the Unreal Engine is using the interpreter pattern among the others. Yeah, many games and game engines just love using the interpreter pattern because it allows so much flexibility that the game can be easily expanded by game designers and even gamers themselves without reprogramming the engine core. Is it for games only? Not really. There are manufacturing and many other systems that follow this approach. So, let's investigate this architecture. I said that it's quite common for games to use the interpreter architecture. So, let's take a look at the example provided in this article. So, the game runs on some hardware and it uses libraries within a game framework to use the hardware efficiently. But the heart of a game is the game engine. I won't talk about the game engines in detail, just want to mention that it implements the core functionality of a game that can be extended. In order to extend it, it must expose methods using API or the application programming interface. These methods are available for extension technologies. And in this case, we have Lua virtual machine. When needed, the game engine will invoke methods on the Lua virtual machine, and Lua will call the exposed API methods if needed. In this example, the Lua can call exposed methods such as getGameState, setGameState, actor_sys, runDialog, pickup_item, hasItem, actor_goToTarget, actor_playAnimation. This way, our Lua code can ask game engine about things in the game state and even update them. The Lua script can start animations and start dialogues. On the other side, the game engine can directly execute functions in Lua. So let's back to the example and let us see some actual Lua code. What this script does is move the main target to the positions of the matches, wait it to arrive there, play use down animation, then check the game state. If Kate is in the office, then let Kate say something about the matches. If Kate is not there, pick up matches, remove the matches from the room, let the main character say something. Finally, return back to the game engine. This behavior is depicted in the sequence diagram. As you can see, the Lua virtual machine works separately from game engine and collaborates to achieve the goal. The game engine is the untouchable part of a system, while the Lua part is accessible for everyone. Let's summarize this lecture. We use this pattern when we need to have the possibility to extend our software with code written in a dedicated language. There are many examples of a successful applications of this pattern. The most notorious one is your favorite browser that uses JavaScript to add dynamics to web applications. When to use this pattern? When you want your users or specialists of your application to be able to modify the behavior of the application. When the rules of your application need to be extended long after the application is finished. Also, if we use the interpreter pattern, we have an additional advantage. We can run interpreted programs in a sandbox and supervise it, so it doesn't do any harm. That's why virtual machine languages such as Java or .NET are safer in comparison to the languages that produce machine code. As always, the good things such as flexibility, control comes at a price. First, performance might be an issue. You can't allow having calculation-wise heavy code within the interpreted programs. Also, interpreted programs might not have support of integrated development environment functionality such as syntax highlighting, debugging, code completion, and many others. So, if you find that the interpreter pattern is a way to go, do it. And you don't need to invent a new language and write the tools to support it. There are many ready-to-use solutions out there. Thanks for watching.